Let us perform an activity for separation of mixtures by sublimation method. Click each tab to know more. Take a china dish. Place 1 tablespoon of chalk powder in it. Add 1 tablespoon of ammonium chloride to the chalk powder. Now, mix them with a spoon. Take a glass funnel which is big enough to cover the dish. Take a piece of cotton and close the mouth of the funnel. Now place the inverted funnel over the china dish. Heat the mixture with the help of a tripod stand and burner. Observe the changes. Initially, we observed the vapors of ammonium chloride and then solidified ammonium chloride on the walls of the funnel while chalk powder remains in the dish. We learned that as the ammonium chloride is sublime after heating, it will directly get converted into vapor, and this vapor will again condense at the upper colder part of the funnel to form solid ammonium chloride. In this way, the mixture of ammonium chloride and chalk powder can be separated by the method of sublimation. Sublimation is the property of substance in which it is converted directly from solid to gas or vice versa. Such substances are known as sublime. Some examples of solids which are sublime are ammonium chloride, camphor, naphthalene, and anthracene.
Centrifugation. The centrifuge is a machine that rotates at a very high speed, and by centrifugal force, substances of different densities are separated. This method is used to separate suspended particles of a substance from a liquid. The process of centrifugation is widely used in dairies to separate cream from milk or curd. Separating immiscible liquids. A separating funnel is used for the separation of immiscible liquids of different densities. Examples are oil and water. A separating funnel is a special flask in the shape of an inverted cone. It has a mouth at the top and a stopcock at the bottom. The mixture of immiscible liquid is filled in the separating funnel placed on a stand. It is allowed to stand for some time. The two liquids form distinct layers. The lighter liquid comes to the top and the heavier liquid settles at the bottom. Now the stopcock is opened and at first the bottom layer is removed. When this is finished, the top layer is removed into another container. Thus, we can separate the two liquids.
Distillation is a method of obtaining pure liquid from a solution. In this process, the solution is heated so that the liquid evaporates. Let's understand this with an experiment. Take some salt water in a retort and heat the retort till the steam comes out of it. We will see the steam getting collected inside the beaker in the form of droplets of water. The steam condenses and reaches the beaker, and the salt left behind in the retort. This method of separation of soluble solids from liquids is called distillation. Now, let's see how can we separate insoluble solids from liquids with an experiment. To separate the mixture of sand and water by filtration, take a round paper and fold it to make a cone and place it over the flask. Pour water mixed with sand into the funnel. You will observe that clear water will get collected in the beaker and the sand will remain on the filter paper. The pure water collected is called filtrate. This method of purifying water is called filtration.
Let's take an example. Separation of acetone and benzene by fractional distillation. As the difference in boiling points of acetone, whose boiling point is 329 Kelvin, and benzene, whose boiling point is 353 Kelvin, is only 24 Kelvin. Their mixture can be separated by the process of fractional distillation, using fractionating column. Let's see how this can be done. The mixture is taken in the distillation flask. Fractionating column is inserted between distillation flask and Liebig water condenser. The flask is heated on water bath. At a steady temperature of 329 Kelvin, acetone distills out and is collected as first fraction in the receiver. The vapors of benzene are cooled in the column, and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising, and the receiver is changed. When the temperature becomes steady at 353 Kelvin, benzene distills out, and is collected as second fraction in the receiver. Acetone and benzene can be further purified by redistillation. Using simple distillation apparatus,